Hello and welcome. In this Max tutorial, we will draw simple shapes using jit.gl.pix Codebox. So this is the second installment in a series on some fundamental jit.gl.pix Codebox techniques. So instead of doing larger patches on very specific visual effects, I want to showcase more general and fundamental concepts. So each video will be self-contained and hopefully more beginner-friendly. So the concepts I'm discussing in this video can also be seen in some previous tutorials of mine, but then, of course, in the context of a different topic. So the topic of this video is drawing simple shapes, and the idea is always to manipulate the UV coordinates in a certain way in order to create those shapes. This video consists of two parts. In the first part, we're going to draw a circle, and in the second part, we're going to draw a rectangle. I will start with a JIT world object here as our rendering context, because we're working with textures. So we need an OpenGL rendering context. Here I have a JIT P window. And I don't need an input video this time because we're going to create our own visuals just by manipulating the UVs from an input texture. Okay, starting with the first part, creating a circle. I will start by creating a texture. Let's give this the dimensions 1920 by 1080, so full HD. Then I will use a JIT bang object, which will bang this texture on every frame. Then we can plug this in here, turn this on, and now we can see the default texture image. Okay, putting this here, and now I can create a jit.gl.pix Codebox, and everything else will happen in here. So first I want to take a look at the UV coordinates in order to explain what's going on. So we could just say out1 equals norm because normalized coordinates are the UV coordinates, but I will make it a bit more explicit and say UV equals norm, and then we can output the UVs here. And oh, of course, we also need a semicolon here. Okay, so as you can see on the x-axis, the pixels here are ranging from 0 to 1, represented by the red channel, and on the y-axis, they're ranging from 0 to 1 in y direction, represented by the green channel. So if I'm just doing something like this, taking the x component, you can see here we're going from 0 to 1, and the same is true for the y component in another direction. But in order to draw a circle, we don't want the coordinates to go from 0 to 1. We want them to go from -1 to 1. We can achieve this by just saying S-norm, which stands for signed normalized coordinates. But I want to create my own signed normalized coordinates, and I will show you in a minute why that's the case. So in order to scale this, we can say UV equals, and then we can use the mix operator. So the mix operator takes a minimum, which is -1, a maximum, which is 1, and then we can use the inputs, so these UVs, to interpolate between them. So, oh no, sorry, UV. So if the UVs are at 0, they will be stretched to become -1, and if they are at 1, they will stay at 1. And now we have essentially the same thing. What I want to do now is finally draw the circle. So in order to do this, we can use the length operator. So we can say circ. And the thing is, we can't use the word circle in here because there is already an inbuilt function called circle, which doesn't work if I'm not spelling it correctly. But yeah, so this is not used to draw a circle with the UV coordinates as we're doing, but these are 3D coordinates for a circle, and you could use them, for example, with a jit.gl mesh and then draw a circle in 3 dimensions, which is not what we want. So this is why I will just call this one circ. Let's set this to 1. Then we can put it here. Okay, and in order to draw a circle, we can use the length operator. And then we can just use our UV coordinates. And now this is, yeah, almost looking like the circle I want to achieve, but now we have this gradient, so we can do something like if this is bigger than 0.5. Okay, so why does this work exactly? So if I'm using the UVs here and then I'm turning this into a comment, we can take a look at the length operator and at the UV coordinates. So the length operator gives me the distance from the center to each point. So when we're near to the center, this distance is very small, so the output will be a low number, so a very dark pixel. And if we're somewhere here, the output is bigger, so this will be a higher number and therefore a lighter pixel. And this is essentially what we're getting here. So here the distance is very small and here the distance is very big. And if I'm not stretching this, so if I'm just taking the normalized coordinates, you can see that the distance, or that the center is up here because the point 0, 0 is here. But if I'm stretching it, I have 0, 0 in the middle. Here I have minus 1, 1, minus 1, minus 1. So the distance is big here, and it's the same as with the other corners. Okay, that's why we're doing it like that. I will create a parameter and call this one scale. Set this to 0.5, and then we can do it like that and say, okay, if this is bigger than scale. But actually I want to have it the other way around because I want a white circle on a black background. Okay, as you can see, this circle is stretched because in order to draw a proper circle, we also have to take the aspect ratio into account. And to do this, we can say ratio equals and then create a new vector. Here we can say, okay, dimension, so the x dimension divided by the y dimension. For the x-axis and for the y-axis, we just have the 1. And now we can scale it by the relationship of those two axes. So in order to apply this, we can just say UV times equals scale. No, sorry, not scale, but the ratio we just created. And now this is a proper circle. And if we are accessing it from outside the code box, you can see that 1, so maximum, means that we have the maximum on the y-axis because it's the smaller one of the two. Okay, this is almost it now. What I want to do is I want to turn this into a function. So it's not just like a block of code, but a proper function so we can reuse it. In order to do this, I will call the function circ. Again, I'm not calling it circle because there already is a built-in function called circle. Then as an input for the function, we want UV coordinates. We want a scale. And we also want a position. But before I'm putting this in here, I will test out the position here. So creating another parameter, call this one pos for position. And now, because I want to position this in 2D space, this will be a parameter consisting of two values, one for x and one for y. Okay, 0.5, 0.5. I want 0.5 to be in the center. So in order to do this, I can just subtract the position from the normalized coordinates and then add 0.5 back in. So now, if I'm changing the position, so 0.5, 0.5 is in the center, then I can change it on the x-axis, and here I can change it on the y-axis. Okay. Okay, now we're ready to create a function out of this. So we have as an input our UV coordinates, our scale, and our position. Then I can take this whole thing. I mean, we could also just leave this outside of the function and then have another, and then put another parameter for the ratio in here, but I will just leave it like that for now. Okay, what's important now is that we can't reassign inputs to functions. So for example, this UV, we can't just say UV equals norm minus position, because this would mean that we're reassigning what we're getting here. So in order to avoid this, I will just say that the input is underscore UV, and then here I can say UV equals underscore UV minus the position, and then here I'm scaling it, applying the ratio. And then here we're not saying circle equals this, but we can just say return, and then we're returning this circle. So I think that's it. So in order to set this as our output, we can say circ. Then here we have to create our UVs. Again, we can say norm. Then we can set them as an input here. Then we can set the scale as an input here and the position as an input here. And yeah, it's still working. And the cool thing about doing it like that is that when we're changing the UV coordinates, we're also changing the circle. So we could do something like multiply this by, I will make a comment here and then set the output to our UV coordinates. And if I'm doing something like this, multiplying it by 10, so now, oh, sorry, didn't mean to do that. So now they're ranging from 0 to 10 in both axes. But if I'm using the wrap operator and I'm saying, okay, wrap this between 0 and 1, you can see that this whole thing is repeating. And now the cool thing is that the circles will also be repeating. Or we could do something like 5 and 7 or 5 and 7t. Yeah, I think you get the idea. Okay, I think that's it for the... Oh. Of course, we need some kinds of UV coordinates. Okay, I think that's it for the first part. So in the second part, we're going to draw a rectangle. So I will take this whole thing and put it to the side. And then create another jit.gl.pix Codebox for our rectangle. Okay, something. Okay, this is not relevant anymore. Okay, coming to the rectangle. So there are many ways to draw a rectangle. the one I'm showing you is probably not the most efficient, but I think it's the most explicit in terms of looking into, okay, what are we doing with the UV coordinates? Okay, so starting with UV coordinates, UV equals norm. Then I'm setting an output. Okay. So far so good. We already know what's happening here. So what I want to do now is I want to define a parameter that's called scale. So this is the size of our rectangle. Oh, sorry. Like that. And here I want to have a scale for the X direction, a scale for the Y direction. So maybe do something like 0.5, 0.5. And I also want a position. So where this is located on screen. And yeah, let's also set this to, so 0.5, 0.5 should be a center. And I think I will make this one a bit smaller. Okay. So I want to start by defining the rectangle in terms of its X position. So let's create a variable, call this one X. And then we can use our UV coordinates and our scale and position to draw something. So we could say X equals the position if it is smaller than the UV coordinates. And then, of course, we only want the X component of this one. So looking at this, we know that the position is at 0.5, so exactly in the middle. And if we're smaller, this is not part of the rectangle. If we're bigger than this, this is part of the rectangle. But this is just 1/2. So we also need to define, okay, what happens on the other side of the rectangle. And in order to do this, we can use the AND operator. So this means that both of the conditions we're about to define now have to be true. So in order to get the edge on the right side, we need to take the position and the scale, because this essentially defines the rectangle. So it starts at the position and it ends at the position plus its scale or its size. So we can essentially copy this and say position plus scale. If this is bigger than UV, yeah. Now we can see that it starts at 0.5 and the scale is 0.25 or the size. We can also define our Y part in terms of this. So let's set the output to Y. Here we can just swap out all the X's for Y's. And then we can see that the same thing is happening in the Y direction. And in order to draw the whole thing, we could say something like rect equals X and Y. So this means essentially that both of those conditions have to be true, or if a pixel is white in both of those cases, it will be, the output will be white. And then we have to set this down here, and then we can see our rectangle here. What you also might notice is that we have the same scale for X and Y. So in this case, we would expect a square, but we saw something similar happen with the circle. So we also have to take the aspect ratio into account here. In order to do this, we can say, we can essentially just copy what we have here. Say ratio is this. And then our UV coordinates are normalized coordinates times the ratio. But yeah, when we apply something like that, first we have to shift it, then apply it, and then shift it back. So because we want to have 0.5, 0.5 as our center, we have to do something like this. We have to say normalized coordinates minus 0.5 times ratio, and then add the 0.5 in again. And of course, so. And for the position, we have to do the same thing. For the position, we have to say position equals, because now the square starts at our position, but I want the position to be in the center of our square. So we have to shift it by half the scale. So in order to do this, we can say position equals position minus scale times 0.5. And of course, we cannot do this because we are not allowed to reassign this. So I will do the same trick as I did here. I will just say the input is underscore position, call this one underscore position, and now it's in the center. So here we're shifting it in order for this position to be in the center. And here we're shifting it again in order to apply the ratio and then shift it back. Okay, as I said, this is not the most efficient way to draw it, but I think it's very explicit what is happening in terms of X and Y. So now I want to, essentially do the same thing as here. I want to turn this into a function. And functions always have to be declared before our parameters. So I'm doing it up here. So I will call this one rect. Then I can copy all of this. So what do we need as an input? As an input, we need the UVs, and essentially it's the same as we did here. So I'm doing it with an underscore, so it's not getting reassigned. Then I want the scale and I want the position. And okay, now I will use underscore position. So this seems to be fine. This needs to be underscore UV. And instead of saying rect equals, I again can say return this thing here. Then let's see if this worked. So again, UV equals normalized coordinates. Then UV as an input. Then here I don't need this underscore again because I'm using it here and then it's reassigned like this in here. So I think we can just say scale and pause. Okay, now here it is. And of course we can do the same thing as we did with the circle. So we can say norm times 10 and then wrap this between 0 and 1. And now we have a lot of them. And we can also change the scale. And the position. Okay. And what's also very cool about this one is that we can also apply the rotation that we did in the first installment of these videos. So in the last video, I showed how to rotate a texture, and we can do the same thing and apply this rotation to our UV coordinates we're using here. So I will quickly showcase this, and I will not talk about this in detail because I already explained it in the previous video. So in order to rotate, again, we need the ratio, because if we don't take the ratio into account, we get some weird distortion when rotating it. Then What we also need is an anchor point for the rotation. So this can be the center for now. And we need an angle to rotate it by. Okay, I think I will run out of space soon. Okay, so I have the anchor, I have the angle, I have the ratio. Then I need to define the UV coordinates, but I need to subtract the anchor and then apply the ratio. Then I will create my polar coordinates. So I have a radius and an angle, and then I can just say car to pole and use UV. So the this needs to be a point, the X component and the Y component. Then I'm turning this back into X and Y with the pole to car. So here the input is the radius and the angle we created. And then our new UV coordinates are this X and Y. And because we multiplied it here by the ratio, we have to divide it here by the ratio to get it back and then apply the anchor again. So is this correct? So we have the ratio, then we're subtracting the anchor, then applying the ratio, then we can apply the rotation, then dividing by the ratio and adding the anchor back in. So theoretically this should be working. Okay, no errors. Let's see. And of course I have to add in the angle that we created up here. Oh, but in radians, because pole to car needs radians and not degrees. Okay, and if I didn't make any mistake, then I should be able, yeah. Now I can turn this up here. So as I said, if you're changing the UV coordinates, you can also change what this looks like. So of course, you could also draw other shapes by manipulating the UV coordinates, and I will put a link into the description where you can find some other functions that can draw other shapes, but I think this is as far as I want to go to keep it beginner friendly. Yeah, I hope you found this useful. Thanks for watching.